Hey, good morning, good afternoon, good evening. Ladies and gentlemen, my name is Petr Plodík and I will talk about our designs and implementations of NVIDIA HPC and AI supercomputers in the Central and Eastern Europe region. These systems are based on NVIDIA Tesla and also latest Ampere accelerators, as well as NVIDIA DGX systems. And I would like to show you our experiences, observations, or lessons learned from our implementations. When preparing this presentation, I divided it into three groups or three approaches how build these systems. First one is just simple implementation of single NVIDIA DGX system. Secondly, the complex IT infrastructure based on NVIDIA reference architecture. And thirdly, these are tailored solutions with NVIDIA accelerators, often inspired by NVIDIA reference architecture, but often with some special requests and features. And at the end of the presentation, I will describe 7 steps how to successfully implement HPC and AI projects, and I will provide you a list of links to related information and mentioned projects. So let's go. First, let me talk a little bit about M Computers. We are based in Czech Republic with branches in Prague, Brno and Zlín. And for NVIDIA, we are so-called Elite partner, which means the highest partnership with NVIDIA. We are active in the Czech Republic and Slovakia, but thanks to our experiences in HPC fields, we are also covering surrounding countries, like from Poland and down to Hungary, Romania, Bulgaria, or countries of former Yugoslavia. But basically, we are system integrator of HPC and AI infrastructure. So we are delivering supercomputers, servers, together with high performance and large scale storages, then also networking and full stack of software. And like we integrate everything to the data center. So often we help with the data center infrastructure, so also like with cooling and power equipment. And what might be also interesting, we are part of NVIDIA test drive program, so we have available the latest NVIDIA technology for testings and proof of concepts. First, have a look at the simplest implementation of supercomputer. Here, NVIDIA introduced great products from DGX system family. You may remember DGX1 system. It was with 8 Pascal or Volta accelerators, or maybe DGX2 system with even 16 Volta V100 accelerators. NVIDIA offers at this moment 2 systems. Volta-based AI workstation, DGX station, and the latest AI supercomputer called DGX A100 with 8 Ampere-based chips A100. And we really love that each single DGX system is all-in-one solution of supercomputer. So you can find here CPUs and GPUs. Actually, here we look more for GPU resources, then the fast local storage on SSDs or NVMe drives, so for data processing, and then connectivity and full software stack to run HPC and AI applications. In fact, these applications are ready to run like minutes after delivery of the system, and we could really prove many times in the front of our clients that this is true. You can see a picture of DGX software stack on the right side of the slide. So on the on hardware, there sits host operating system, usually Ubuntu, Linux, or Red Hat, then NVIDIA drivers and software to run application containers. You can download these containers from NVIDIA NGC, which is a repository of pre-configured and tuned HPC and AI applications or frameworks. You can download here also pre-trained models. The first single NVIDIA DGX system scenario is great solution to start and test HPC and AI application. It could be great for department or work group workload when the required performance can fit into one node, or DGX A100 could be populated with 8 fastest A100 accelerators that can offer up to 5 petaflops of AI performance, and you can divide this DGX A100 system into 56 GPU partitions that can be shared by your scientists or users. With the DGX system, you will get NVIDIA support that can cover both hardware and software stack. And yeah, we think this is really great for troubleshooting in case that something is wrong. So you can talk to only one company, to NVIDIA, to solve or fix your problem. Here is the quick look to NVIDIA NGC portal, and you can see the content for many different types of HPC and AI workloads. Like here you can find natural language processing, image classification, or down there are some collections from specific business or industries, like healthcare in this case. Here you can find the link. You can access NGC cloud, so ngc.nvidia.com. I would like to show you 3 implementations of so-called single DGX system. The first one is DGX2 at IT for Innovations National Supercomputing Center in Ostrava in the Czech Republic. And it was actually the first DGX2 supercomputer in Central and Eastern Europe region. It is used mainly for testing and development of HPC and AI applications and algorithms on this large-scale 16 GPU system. They are also using this system for trainings under PRAISE initiative. The second example is DGX station at the University of Defense in Hradec Králové, so also in Czech Republic. This NVIDIA workstation is used to run molecular dynamics tasks, applications like GROMACS in department kind of deployment. So this is the reason why they choose this silent and water-cooled version of system. And the third project is about special version of DGX1 called MaxQ for research organization. CIRC means Czech Institute of Informatics, Robotics and Cybernetics under Czech Technical University in Prague. And DGX MaxQ is the system tuned for the best performance per watt. We have delivered 5 systems there. 4 systems are part of job scheduling system of current cluster infrastructure, while one system, one DGX1, is dedicated for a research group, one particular research group. And this is why I put actually this project here under single DGX system, because this research group can use DGX1 MaxQ as independent system, independent unit. Now let's move to the second group of AI supercomputers, more complex. And when we have more AI systems, we need to connect them together, provide them high bandwidth data access, and think about management software that can deploy, monitor, or schedule workload to better utilize the whole infrastructure. And in this case, we can inspire by NVIDIA DGX reference architecture. The best practice is how to build actually large supercomputers. In our case, we selected ONTAP AI reference architecture with NVIDIA, NetApp, and Cisco products, and I will describe you later the reasons of this choice. It's very important for this complex architecture to consider data center environment. Do we have enough space, power, and cooling capacity for such system? So it's not an easy task, and it consists many different IT ideas behind. NVIDIA DGX reference architecture is a book indeed, so you can read it. You can understand performance expectations of your solutions. And this is usually based on the real AI training and inference benchmarks. We also used NVIDIA support during implementation of NVIDIA DGX reference architecture. For example, they helped us to tune management scripts. And you can see several components of management stack in this reference architecture, including workload schedulers like Slurm or Kubernetes. So it's quite a power architecture, and as I said, it covers both hardware and software stack. Here you can see example of NVIDIA DGX reference architecture we delivered to our client. Basically, you can see 4 NVIDIA DGX2 systems connected together by 100 gig Ethernet with RDMA over Converge Ethernet support. And down you can see disk array storage, NetApp AFF A800. And again, this storage contains 100 gigabit connectivity. There were also management servers in the configuration, and these servers run management stack from NVIDIA. This architecture was actually exactly according to the ONTAP AI NVIDIA DGX2 pod. So I think it's a nice showcase that everything was working very nicely according to this architecture. It was not easy to select the right NVIDIA DGX reference architecture solution. NVIDIA offers this architecture with NetApp, Dell, IBM, Pure, and also DDN storage. But during the time we were doing the research, and it was around 2 years ago, only NetApp was able to fulfill all requirements, and also was flexible to provide reasonable price to us. But I think this is not a general statement. Please bear in mind that we are in the Central and Eastern Europe region, and some storage and network vendors don't have branch office here. And surprisingly, also NetApp is not presented here, but NetApp is represented by Aleph Distribution Company. And we really appreciate the work with sales and technical guys from Aleph Distribution, and with cooperation of NetApp guys, we found the best architecture for our clients. Aleph guys helped us also during the implementation phase. but there were also some technical advantage of NetApp solutions over the competition, like 100 gig storage connectivity of NetApp AFF A100 system, or some of our clients requested seamless integration of Windows application and Windows access to storage, like with CIFS protocol. And actually we are cooperating with Aleph distribution and NetApp guys in other projects, in new projects. To the third group of AI supercomputers belong custom solutions with specific requirements. We call them tailored solutions, and they are great for mixture of CPU and GPU workloads when you need to put together different server architectures, clusters, big SMP systems, fabrics with different speeds and technology like InfiniBand or Ethernet, and mostly also different kind of storage solutions like super fast scratch storages or scale out or object-based systems, often built on software defined storage. We are also discussing cooling options, and it seems that liquid cooling will be a hot topic for next year's together with reuse of heat from data center. So these are tailored solutions, the specific solutions. And let's have a look at one example of tailored solution of supercomputer. We have implemented it at the Faculty of Electrotechnical Engineering at Czech Technical University in Prague. The cluster is used to run several research AI and HPC projects with many applications and with many different hardware requirements. So you can see here dual socket systems, CPU nodes, several 4 GPU nodes populated with NVIDIA V100 accelerators in SXM2 slots, and 8 socket SMP systems. All nodes here are connected by EDR InfiniBand, and for like inter-node communication, and 10 gigabit Ethernet for storage interconnect. And for the first look, you can see there is no scratch storage here. It is there indeed, but all compute nodes in the cluster are populated by super fast NVMe drive, and with we created a scratch storage on the top of them using a BGFS file system. This file system, together with Slurm job scheduler, can use the functionality, so we can dynamically create disk volumes in the file systems when needed, based on like job scheduler. There is also future extension planned for this project based on latest NVIDIA A100 technology, HDR InfiniBand, and 100 gig Ethernet technology. We have then more references of tailored solutions. So we just described the one at Czech Technical University. Then we have several projects at Czech Academy of Science for biochemistry, physics, or data analytics from different kind of data acquisition systems. We have nice stuff and references at the Masaryk University in Brno to CERIT SC and CEITEC projects. Here they have broad portfolio of NVIDIA accelerators from Quattro to Tesla, like for T4 and V100 systems. I like the reference at Tomáš Baťa University in Zlín. It is the fresh one to Department of Informatics and Artificial Intelligence. And they have several V100 accelerators in SXM2 versions. I also like the reference of interesting supercomputer with NVIDIA T4 cards to check startup Quantasoft. They are doing computer vision, biometrics, and AI, and I believe that they have the best algorithms I could see for very precise face recognition. Lastly, we have the fresh implementation of latest NVIDIA A100 accelerators at Slovak Academy of Science. It was upgrade of their AI systems. At the end, please let me summarize a little bit how we design and implement HPC and AI projects in 7 steps. At the beginning, of course, the first contact, we have, I believe, quite unique NVIDIA microsite with the latest NVIDIA enterprise products. We try to concentrate all information and content from different resources on this microsite, so you could find, I believe, everything here. Then you can contact us via email, or you can find us on NVIDIA Partner Portal. Secondly, we are starting the discussion from your HPC and AI application requirements. So our consultants have quite a lot of experiences from previous projects, and this is one of the reasons why we have top NVIDIA partnership called Elite. We have also access to NVIDIA tech guys and specialists on many different HPC and AI topics. We usually prefer to test the application first on the latest technology. So we are doing quite a lot of proof of concepts during the year. And thanks to NVIDIA Test Drive program, we have access to BGX station, NVIDIA accelerators, A100, V100, T4 cards, or Jetson products. On the next steps, 4 steps, we design your architecture. So either using NVIDIA reference architecture or tailored solution. We can offer implementation of complete solution, often using NVIDIA software stack and support for DGX-based solutions. After implementation, we tune and test the solution. So also here we can use NVIDIA support in DGX solutions, and it works really well. And at the end, we like NVIDIA Deep Learning Institute and provide training for both online or instructor-led workshops to get the best from install AI supercomputers. So this is like in a nutshell 7 steps how we design and implement HPC and AI project with our clients. Well, that's all. So here you can see some links to resources used in this presentation. So you can visit the sites, review them. And thank you very much for your attention. And I'm looking forward to do some HPC or AI projects together. Thanks a lot for your attention. Have a nice day.